In the quiet corner of a farmhouse outside Falköping, Sweden, stands a sentinel of white ceramic tiles, a monolith reaching from floor to ceiling. It measures roughly 2.5 meters in height and nearly a meter in girth, yet it possesses a ghostly presence. No roaring flames, no crackling embers, and zero smoke. However, to touch its surface is to experience a physical paradox. Hours after the internal fire has been extinguished, the ceramic skin radiates a profound, penetrating warmth, the exact sensation of a granite boulder that has soaked in the high-altitude sun all afternoon. This is the Kakaloon. For over 2 centuries, this tile stove was not merely a piece of furniture, it was the biological heart of the Swedish home. It dictated the architecture of survival, heating the rooms where life unfolded, sleeping, eating, and laboring. By the 19th century, Sweden, a land defined by its brutal subarctic climate, boasted the most efficiently heated residences in Europe. This was achieved through a radical engineering philosophy, maximizing comfort by minimizing consumption. A single Kakaloon, fed with a modest fire for only 2 hours, could hold a room in a state of thermal grace for an entire day, consuming as little as 1 medium-sized tree per year. In our contemporary world, the Kakaloon has been relegated to a footnote of Scandinavian history. During the mid-20th century, the arrival of electric central heating triggered a mass cultural lobotomy. Thousands of these sophisticated thermal engines, which had shielded generations from the lethal Nordic winters, were systematically demolished. They were replaced by thin, soulless metal radiators, devices that offered immediate gratification but zero resilience. This is the saga of the Kakaloon, an investigation into its ingenious mechanics, the national crisis that birthed it, and the sobering lesson of what happens when a society trades its most resilient technology for the fragile illusion of modern convenience. To view the Kakaloon as a decorative luxury is a historical fallacy. It was forged in the crucible of a national emergency. Between 1500 and 1800, Europe endured the Little Ice Age, a period of climatic brutality where winters were marathons of ice and darkness. In Sweden, the crisis was compounded by the Industrial Revolution's insatiable hunger for iron. Smelting iron ore required gargantuan quantities of charcoal, which in turn required the systematic clear-cutting of Sweden's ancient forests. By 1647, the forest canopy was vanishing at such an alarming rate that the government enacted some of the earliest conservation ordinances in human history. Yet the domestic reality remained bleak. The standard heating method, the open fireplace, was an engineering disaster. It lost upward of 90% of its thermal energy through the chimney, effectively burning the forest to heat the sky. Families were forced to burn wood from dawn until dusk, just to maintain a precarious margin of survival. Sweden was quite literally running out of its most vital resource. In 1767, the Swedish crown reached a breaking point and commissioned the Royal Academy of Sciences to intervene. The task was assigned to an unlikely duo, Carl Johan Cronstedt, an architect-engineer, and Fabian Reed, a military general. Their objective was a masterpiece of constraint: design a heating system that produced vastly more heat while consuming a fraction of the wood. Cronstedt's foundational insight was a pivot in human logic. He realized that the primary obstacle to warmth was not the lack of fuel, but the failure to capture the energy already liberated by combustion. The goal was no longer about burning, it was about sequestration and delayed release. Kakaloon, however, forces the exhaust into the atmosphere. The Kakaloon, however, forces the exhaust into a strategic internal labyrinth. The internal body is carved into 5 distinct vertical channels. The hot gases are forced to ascend the first, plunge down the second, and zigzag through the remaining 3. Every turn is a thermal transaction. The smoke is compelled to surrender its kinetic and thermal energy to the heavy masonry walls before it is allowed to exit. While a standard fire vents at a wasteful 400 degrees Celsius, A Kakaloon's exhaust temperature is stripped down to a mere 100 to 150 degrees Celsius. This 250-degree difference represents the energy harvested and stored within the home, rather than discarded into the atmosphere. Built from an immense mass of brick, sand, and mortar, weighing up to 1.2 tons, the stove acts as a high-density thermal battery. A short, high-intensity burn charges this battery, which then discharges heat slowly through its ceramic skin via far-infrared radiation for up to 24 hours. From the perspective of a sustainability designer, the Kakaloon is the gold standard for healthy, autonomous living, offering benefits that modern HVAC systems are physically incapable of matching. Most modern heaters rely on convection, heating the air itself. This creates a stagnant loop of dry, dust-laden air that irritates the respiratory system and desiccates mucous membranes. The Kakaloon, however, emits far-infrared radiant heat. Like the sun's rays, this energy warms solid objects in human tissue directly, leaving the air fresh, oxygen-rich, and naturally humid. It provides a deep bone warmth that promotes circulation and cellular recovery. In an off-grid scenario, every watt of energy must be leveraged. The Kakaloon serves as the life coordination center. Because its exterior stays at a safe, consistent temperature, it becomes a versatile tool, a place to proof sourdough bread, dehydrate seasonal herbs, or dry heavy work gear. It is a zero-waste ecosystem where the act of heating the home simultaneously supports food preservation and sanitation. The introduction of the Kakaloon triggered a spatial revolution in Sweden. Prior to its invention, winter life was a huddled, smoky existence confined to the immediate vicinity of a failing fire. The Kakaloon made entire homes habitable wall to wall. Because it produced no smoke and required minimal tending, rooms became clean, quiet sanctuaries for work and rest. Cronstedt's decision to publish his findings in 1767 transformed the stove into a public utility. It crossed all class boundaries, from the gilded, hand-painted porcelain stoves of Stockholm's palaces to the rugged, unadorned versions in peasant cottages. It provided the most precious commodity of all: time. Families were no longer enslaved to the constant labor of felling and hauling firewood. The mid-20th century saw the Kakaloon fall victim to the convenience paradox. As Sweden modernized, three forces conspired against it: electrification, the post-war housing boom, and cultural shame. Post-war society viewed the manual effort of tending a fire as a badge of poverty. We traded a resilient 200-year-old system for electric radiators, devices that are designed for obsolescence and become worthless the moment the grid fluctuates. We surrendered our thermal sovereignty for a plastic dial. In our rush to be modern, we discarded a technology that was inherently carbon neutral and infinitely more reliable than the fragile infrastructure we depend on today. Today, the revival of the Kakaloon is not a retreat into the past, but a leap toward a resilient future. In the face of rising energy costs and climate volatility, we are finally asking the question we should have asked 70 years ago. Why did we abandon the most efficient heating system ever devised? The physics remains immutable. Radiant heat is healthier, thermal mass is more efficient, and 5 channels are better than 1. Whether through antique restoration or new builds from companies like Gabriel Kakalugnar, the Kakaloon is reclaiming its place. In an unpredictable world, the ability to keep your family warm through a sub-zero winter with nothing more than a few logs of wood is the ultimate definition of freedom. It is time to stop trusting the grid and start trusting the bricks in the corner of our homes.